Alrighty, welcome back, boys and girls. It's your main math man, Shank, coming to you live from Summit Academy. And in this video, still working on that wonderful Unit 2 competency. And for that third one, we're now going to be, applying our quadratic applications. So we're saying, at number 3, it says, Mr. Shank is laying siege to Castle Van Tassel using a trebuchet. The king notices that the castle, it hit the castle 36 seconds after the trebuchet launched. The siege engineer also noticed that the maximum height of the ammunition was 162 meters. So with these two values and these two kind of points of information, we should be able to, build our graph and be able to build our function and be able to speak towards it. And so that's what we're going to do in this problem. So in part A, it says create a graph to represent the scenario. So we should make sure that we include the x and y intercepts. We want to make sure that we have each of those points labeled, including the vertex, and then you want to say what the domain and range is going to be. So let's see. I know that when it launches, so let's have that dark green again. It has at the point when it launches is going to be 0, 0, and when it hits is going to be that 0, 36. So I'm going to say, okay, I'm going to have, let's say, x-intercept, and we have x-intercept, and that was at the point, 0, 0, and at the point 36, 0. It also had the maximum height was 162, and that's going to be halfway across, so it kind of makes that N shape, and so that's going to be about halfway across is going to be that maximum height. So I can say halfway between 36 and 0 is 18. So whatever value that is, when it hits, or when that far right x-intercept we want to take about halfway is going to be where we have that value. So I could say something like here maybe. Let's do about right there. We'll say this is going to be the point. We can say this is the point 18, comma 162. That's going to be our vertex, and we're going to call it our max since it's our highest point. And what we can kind of do now is use those three values to connect our points. Let me actually try that again. Do a little bit better this time. Something like that maybe. So we're saying, okay, at those 3 points is those 3 ordered pairs, and that way I can label them. So let's see, what else do I need here? Again, feel free to pause, rewind, whatever you need, so that way you can get that information. So we have our x-intercept, y-intercept. We can also, let me also label that, since the rare case where it actually has our y-intercept as well, we are good. We can also label these vertices, or excuse me, these axes, because I could say, hey, this is going to be our, let's say this is our time in seconds, and let's say this is, we'll use the letter T for this. And then we could say for this one, let's see if I can write this going up and down, something like here. We can say this is going to be, what is this, height? So we're going to say not close. Let me try writing it horizontally instead. That way it's easier to read. Alright, so let's say our y-axis is going to be our height in meters, because that's what it gives. So we're going to say height in meters, and let's use that letter H for this. Okay. Let's also have our domain and range. So I can say, let's say, let me put it up here as well. You can use that space to your benefit. That way you can, be able to see everything very clearly. So I'm going to say, let's say, we do blue. Come up, sure. Let's do our domain D. is going to be an inequality because we're saying, notice how it's a continuous, function along those points. So we're going to say from 0, so our lowest x value is 0. We're saying less than or equal to t, less than or equal to max x value is 36. So that's our domain. And I can do in red, I think. Let's do purple maybe. One of those two. Try it out. Yeah, sure. Okay, and we'll say our range for this function, what's our lowest y value? It's 0, and our highest y value is going to be 162. There it is, 162. So again, find your highest and lowest points. That's how you build your domain and range. Make sure you label it appropriately. Again, you use those letters that we determined for ourselves. And then what do we have next? So we have create a graph, we have our scales, we have our axis labels, domain range, and identified points. All right. So now part B, write a function to model this scenario. And so I need to come up with a function that works for this equation, or excuse me, for this graph, I should say. So let's do that. So I'm going to write my equation or my function. I'm going to say I have the function h in terms of t. So I have h of t is equal to, since I have that n shape, I have to have a negative leading coefficient. I said I have halfway point, so I have halfway across. Use that vertex form, so that way we can use it like this. I can say, okay, halfway across, I'm going to have, let's have t minus 18 squared, because it's a parabola, and then I can have plus 162. So some parts to be able to build from this. Have it in vertex form. That way you have your, your value x squared, makes that n shape with the negative leading coefficient. And then whatever your vertex is, I can have my x value at that point and is my maximum y value. And so I can then plug those points in to make sure it checks out. So that was part B. For part C, create a table of values to represent the function. Okay, so what we're going to do, let's do like this and create a table. And I actually have 3 points already. So what I can do is this. I can say, all right, I have a table. So I'm going to say, let's do t is my x values and h is my y values. Kind of make a table like this. Let's do, I have the point 0, 0. I have another point in between. Let's actually do it like this. Let's do midway point is 18 and then 162. Another point, and my ending point is 36, 0. Okay, so now you're probably wondering, well, how can I do this? Well, a couple ways you could. You could plug any value you want in for t to be able to solve for it. Again, I usually pick values that are in your domain, and so what you can do is this. Let's actually pull up our wonderful calculator, if I can find it. Okay, so we said our function, and you can type it in exactly as it looks. Hopefully we can say y equals, let's just use x and y values. So I can say y equals negative 1 over 2 times x minus 18 and squared and plus 162. And let me fix this so that way it's in there. So I go from 0 to 36, and my y-axis is, let's say, 0 to 200. There we go. So let's do something like this. Again, it's not going to be perfect. Again, our graph is a little bit, it's dependent on what value. There we go. something like this maybe. Okay. And so what you can do is, if you want to, you can, graph it out, be able to trace along and pick those values. So if I wanted to, I could say, hey, when x equals 9.75, my y value is 127. So you should be able to pick those y values, or what you can do is this. I can say, well, I can pick my x, so I can use this equation, and I can say, all right, let's do this. Let's plug in when x equals, let's say, when x equals 12. You can type in your expression to get your values. So I would say if I go back to my graph, I can say, okay, I have a point when x equals 12. My y value is 144. So that checks out. So I can kind of label. Let me label another point. Let me double check. What was it again? Yeah. So when x equals 12, y equals 144. So let's graph that point. Say about right there maybe. Or actually, let me do a little bit closer. So this is going to be the point 12 and 144. And we just put that in our, we can put that in our table of values. So let me make sure that's a 4. There we go. So just pick 2 x values. You already have those 3 points, and so you only need to do 2 extra points. And so let's go back to our calculator. So I can pick another x value. Let's say, let's pick after, let's do 24. That way it's, actually that would be the same, so let's do 25 maybe. Okay, sure. So again, notice how it kind of has, since it has that curve, that N shape, you're going to have some repeated y values, but that's okay because we're talking about those unique x values. So let me do this. So when x equals 25, my y value is 137.5. So let's pull that up. So we said when x is 25, so when x is 25, it's just right here. I have, so 25 and 137.5. So that's going to be my other point. Again, have at least those 5 values in your function. Got to have at least 5 values, or sorry, 5 x values, so that way in your table you can have those 5 points. So let's check to see. Again, feel free to pause at any point in time. So that was part C. I believe part D, it says identify how you see the x-intercepts and vertex in the table graphing equation. So you can, rewrite it different forms if you want to, so that way you can see a little bit easier. So part D is just something like this. I can say, part D, I can find, my x-intercepts where it hits the x-axis. I can say I know where my vertex is because that's the largest y value. For my equation, I can say that whatever point I plug in, it should go to 0, and whatever's left over is my vertex. For the x-intercepts, we could write it a little differently if we wanted to. That way you could kind of see it a little differently. But I know that in my table that I have, again, I can find wherever x equals 0 is my y-intercept, wherever y equals 0 is my x-intercepts, and then wherever my largest y value is my max. So be able to kind of speak to those different points for your different forms of your function. Feel free to ask questions, and as always, super slam that subscribe button.